Hi, welcome back to the channel. So in this video, we will see what is power supplies with respect to basic electronics or introduction to electronics. So with the help of a block diagram, we will see what is power supply. So we draw the block diagram first. So first block, we will consider in the first block a transformer. So it is not just a transformer. So we can call it as a step down transformer, right? What is the job of step down transformer? So it is going to take the AC supply and it is going to convert into again AC, but it is stepping down the voltage what is having at the beginning. That is the first. So it is first block, and the second block is, we will write it as rectifiers. Right, so here whatever the AC supply is, I will write as a high voltage AC supply is getting converting into a low AC supply. Then this is feeding into a rectifier. So here I am going to get DC voltage and it is a pulsating, right? So after that, one more block, we will call it as reservoir or smoothing circuits, or we can call it as filter circuits. Right? Then the last one is voltage regulators. So it is voltage regulator. Right? So DC pulsating. So if I use here as filter circuits, I will get a DC which is little what smooth, and here it is a pure DC. Right? So this is what the power supply block diagram is. So we will analyze this how exactly it is going to work in case of power supply. So here this overall block diagram is the power supply. So here initially how the AC is looking like this. It is AC voltage or sinusoidal voltage is AC, right? Initially it is like this. So with the help of the proper turns ratio, which is N1 is to N2, proper turns ratio N1 is to N2, so it is going to be, the voltage is going to be reduced, because here what is the main AC supply which is coming? 240 volts. I should reduce this 240 volts to some voltage, whatever it is. Maybe it is 5 volts. Assume that it is 5 volts. We call it as low AC voltage supply, which is required for 5 volts is required for like battery, like mobile charging, like that, right? So for that we will use that. So here at this point I am having a very high voltage like this, which is converting into a low voltage. So here I will draw that low voltage, which is like this. I will call it as 5 volts, but it is what type of signal? AC signal, which is low. After this, a transformer application, right? Then after that, this AC low voltage is passed through a rectifying circuit. What are the types of rectifiers we have seen? Half-wave rectifier, full-wave rectifier, center tap, full-wave rectifier, bridge. Half-wave rectifier is consisting of one diode, full-wave rectifier center tap consisting of two diodes, bridge rectifier consists of four diodes. So with the help of these circuits, what we are doing is we are converting a AC signal into a DC, and it is not the purest form of DC. We will call it as pulsating or unsmooth DC, right? So how we are getting that? So if I go for full wave rectifier. So I will go for the full wave rectifier. So I will get my output, which is looking like this. V, that is output, can be written as VDC. You can observe here. Initially it is VAC, which is low. It is VAC, which is high. VAC high to VAC low, VAC low to VDC, right? And this is, we'll call it as unsmooth DC output, or we can call it as pulsating DC, right? Now, since this is not the exact form of a DC, we will again pass this to the smoothing filters or filter circuits or smoothing circuits, or we'll call it as reservoirs, right? So how we have used the smoothing? For example, if I consider the half wave, it is a diode. Here I will be having a transformer AC. So this is connected to load resistance. So before load resistance, so we should use the capacitor, then after that load resistance. So this is called as a filter, right? So what is it is going to do? So if it is a full wave rectifier, it is just like this. So here we'll be having, right? So this, if I use the full wave rectifier, so it is going to charging and discharging, right? So that I will get the smoother waveform. How the smoother waveform of this circuit after this is? So here it is charging, discharging, charging, discharging. So it is V capacitor voltage I will call, because it is capacitor voltage is nothing but the output voltage, which is VDC we can call, because it is across the parallel. So it is somewhat called a smoother DC, but still not the 100% accurate, because it is, we should convert it into AC to DC rectifier. In the rectifier again it is not smooth. So what we are using here next is voltage regulator. What is the job of voltage regulator? So it should take the unregulated power supply at the input, and it has to give the regulated power supply, right? So for that we will use the voltage regulators. What type of voltage regulators we can use? So Zener diode we can take as an example, which acts as a voltage regulator, so that we are going to get the constant voltage at the last. So it is, this waveform is getting changed to this. So we'll call it as the purest form of DC. That is what the output here we will get, right? You can observe from the starting now. Power supply block diagram is consisting of transformer, rectifier, filter and voltage regulator. Transformer job is converting high to low, high AC to low AC. Then the job of rectifier is it has to convert a low AC to pulsating DC, right? With the help of half wave, full wave or bridge rectifier. Efficiency is more in case of full wave, so we should use this full wave. Then after that again it is not sufficient, so we are getting an unsmooth waveform, so we are using the filter circuit for that to overcome this form of pulsating to capacitor voltage like this. But still this is not okay, then we are sending this to the voltage regulator. Means here it is Zener diode is acting as a voltage regulator, because it also works in the reverse biasing. So its job is it has to give the unregulated power supply to the normal power supply, which will exactly look like this. It's a constant DC. So this is the job of power supplies. Okay, this is there in your syllabus. Very important, the first question it may ask. Okay, thank you. We'll see in the next video. Stay tuned to this channel. Click on the bell icon for the notifications and do subscribe. Thank you.